Hello, authors. Good morning. To your authors and invited guests, welcome to Technical Session 7D. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GS Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 26, Pune, India. The 10th edition of this conference is being held in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th till the 21st of January 2026. If you have any query, you can write it to me in the chat box. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations and 2 minutes for the question and answer. Each presenter will be given 10 minutes for the presentation. On 9 minutes, I will also raise a gentle reminder. I request you all to stay connected with us till the closing remarks. Before we begin with the presentations, I'd like to introduce you to our session chair. We have with us Dr. Surendra Nagar, who is an assistant professor in the Department of CS in Engineering and at the Netaji Subhash University of Technical, uh, New Delhi, India. His academic and research expertise spans data science, artificial intelligence, and DSA. He's actively involved in teaching, research, and mentoring with a strong focus on developing data-driven and intelligent computing solutions. We welcome you, sir.
Thank you, Ishita. Thanks for the introduction.
Thank you, sir. I'll be proceeding on with our paper presentations now. I'd like to invite our first paper presenter, Devene Gold, with the paper titled A Sustainable and Secure Hybrid Blockchain Consensus with Optimization for Digital Rights Management. Sir, if you're ready, then you may start with the presentation.
Yeah, sure, Ishita.
Sure.
Hello. Hello. Am I audible?
Yes, sir, you're audible.
Let me share my slide first. Is it visible?
Yes, sir, it is visible.
Okay. Namaste, everyone. Very good morning to all of you. My name is Devin Gul. Today I'm here to explain about the research which we have worked on the area of blockchain. The title is A Sustainable and Secure Hybrid Blockchain Concept with Optimizer for Digital Right Management. So I will start with the presentation. So digital right management, or you can say digital transport challenges. If you see the current scenario, there are lots of opportunities and you can say challenges because people are moving towards the so you can say the digital platforms. So there is always the opportunities and challenges in the world of digital era. So if you see, everyone have their smartphone in hand and everyone using it, but they don't know how to use it. So again, the content, the data, the information which we share, right, it's globally available to everyone, but there are certain constraints regarding whether the data is authenticated or not, whether it's a copyright protections and transparency, you can say trust is also a key issue, right? So these are the things which we consider as a transfer of transformation which we have seen in last few years. So what basically digital right management, right? So see, most of the time there are always a constraint of copyrights, and we all know that there are certain issues that we need to solve in the area of specifically in a data management system, or you can say digital right management system, which you often fail. So this is one of the proposed work we have proposed in this paper. So we'll see as we progress. Few of the slide I will skip fastly because there are basic information. So in case of any of doubt, you can ask me either in between or later on. So let's start then. So core principle about blockchain. Why we prefer blockchain for DRM, right? So we all know that the blockchain is a buzzing word and people are trying to solve it up. When I say blockchain, people always thought it's a cryptocurrency, but it's not like that. There are certain parameters, certain things which you can extract from the blockchain that can be useful for the real life applications rather than the cryptocurrency. So one of the important decentralization, immutability, then transparency and cryptographic security. So one of the important feature of blockchain, that is immutability. What it means that once the data is recorded, it will be permanent. So no one can, you can say that, compromise the information once it's stored in a blockchain. That is the base thing about the blockchain. So that is one of the important point. If you see the uses of blockchain, not only cryptocurrency, there are certain area like DeFi, supply chain, healthcare, identity management system, and there are other places where people are trying to cope up with the blockchain in future because of security reasons. So this is the one of the solution. The limitation of traditional DRM system. Okay, so see, in traditional, we all know that it's centralized. So one of the key failure is that a single point of failure, and that is the one of the issue that very concern about the security of any data or information. So this is one of the problem. Other, the inefficiency of royalty payments, right? So nowadays people are copying, you can say that, your work, and they may publish, right, with certain modification, or you can say that certain changes, even though they are not authenticate. So the thing is that how can you solve this problem, right? So this is one of the problem you will find in traditional DRM system. The financial impact, as I told you, sometimes you won't get paid before, even though it's your work. So these are the things. The benefit of DRM, as I told you, so it's give you the permanent ownership of your information. It's a non-fungible token, one of the use case of you can say that about the blockchain that we have heard about. So the concession mechanism. Now, next point. So see, all these are the different parameters I'm introducing in very short manner, right? So concession mechanism challenge. So again, the problem is what about concession? So how can we get agree to the particular statement, right? So there is always a requirement of, you can say that, if we don't want to go centralized, then we have to go for decentralized. If we go for decentralized, then there is a concept called concession mechanism, right, in blockchain. So how you come to the agreement? So that is one of the key challenge in a particular of blockchain domain. So security and trust is a very major important role to face in this kind of consensus mechanism. Okay, so as I told you, there are certain algorithm available, but every algorithm has some importance. Some, you can say that there are some merit and demerits, right? So what we do, so we have published our paper on hybrid consensus mechanism, right, in 2025. So in that we have proposed the mechanism how can we get better result with power consumption, as well as thinking about the role of decentralized in a base manner way. So if you combine certain features, right, from the different algorithm and try to make it a better way, so that DRM can be get faster and executed in efficient manner. So you can see there are certain features that need to take care about difficulty adjustment, then streak based random validation, selection slashing, that you can have penalties based on the behavior of individual, and so on. So these are now the we will discuss about the 6 phases of algorithm in very brief manner. So first we need to do block creation, then stack collection, validation selection, block validation, difficult adjustment, slashing. This is how the algorithm will work in a network. So there are certain things which we need to understand when we do all these things, right? So difficulty adjustment, validator set. So all these have certain features. I'm not going in much detail about the mathematical component behind this algorithm, because this is already published previously. So I'll give you the brief idea. Certain parameter you need to set, right? So let's give me an example of difficulty adjustment. So difficulty is one of the key concept of blockchain, because it's a one puzzle that you have to solve when you mine a block. So if the difficulty level is high, then the problem is that it will take more time to execute. It will take more time to complete the you can say the transaction in the blockchain. So if we keep less difficulty set, then it's faster to propose the block. So how can you make it relevant, so that it will be not faster, it will be not slower? So that is one of the key parameter that we have identified. So we can cap these factors alpha, right? So in between the adjustment late, I mean, based on the block proposal time, you can modify this. These are the key parameter, configure parameter, that we have included for the transaction of blockchain in our algorithm. So blocks, transaction nodes, again, see, these all are the parameters that you can modify as per your need. So if you want faster transaction, you can do certain modifications according to that. If you want slow transactions, you can go for that. If you have more number of nodes, then the transactions and the network require high computation power, because ultimately it's a decentralized network. So that's all about that. Now we'll see in little bit more detail about the algorithm. So if you see in first step, we create the block which will have the hash value. Again, hash value is all about the blockchain. So we don't know about the certain metadata about the information of blockchain, I mean block. So based on hash value, we can identify whether the block is valid or not valid. Second, we have the stack aggregation and validator selection. So we need to do not only the based on the, you can say that, puzzle, but we have to also think about the stack as well. Stack you can also be considered as a part of blockchain, and the stack value will be calculated based on the total summary of stack in a network. with the probability of adjusted value, and based on this formula, right, weighting of step with probability, we can finalize the person, so it will get fair chance to everyone in the network. Then third points is finality. How can we finalize the block, right? Or what is the way you can finalize the block validation in a network, right? So this is one of the thing. We will keep the verification minimum time that we can cap, so that if it is greater than this, then we can propose the block. You can consider the block as a part of validation, and you can finalize the block. Once the block is finalized, it's irreversible. You cannot modify the data or information. Then again, as I told you, difficulty. So difficulty is also important. As per the, you can say, the requirement, difficult we can be modified as per your need, right? This is a flow of DRM system, again, how it will be used in blockchain. So right from registration, content distribution, consumer access, royalty distribution, these are the phase we need to understand, we need to keep as we progress in a blockchain. So these are the first steps that we apply to the consensus algorithm. I mean, before consensus algorithm, these are the steps we have to do for DRM. These are the review result and company analysis that we have kept. So based on, see, as I told you, these are the few algorithms we have kept from the other tools, right? But there are other algorithms that you can compare based on the analysis. But we have kept because of hybrid propose. We have used proof of work and proof of stacks features to enhance the results. So we can see that the proposed work is better compared to the feature of blockchain of proof of work and proof of work. But there are certain parameters we need to understand, that dual security variance is always better in OHCM. I mean, optimal hybrid consensus algorithm, where you can see that if the the security parameter is moderate compared to proof of work. The reason is that because proof of work is have higher difficulty level but time consuming, so that is why there is a difference in that. Now the next parameter, next thing. So again, we can also make it that based on the network, right? So there may be standard unsolidated network or relay network or send header network. So based on the information kept in the blockchain, it will be faster to execute or faster to provide the information in a network. So these are the 4 different networks. So based on this information, it will automatically give you the result. So whether you want to go for standard, unsolidated, or which information you want to kept in a block network, that you can kept. And these are the results. So based on this 4 network or 4 information, you can have any of this network information as per your need, and based on that, it will give you the information. Now the last part of the slides, advantage of DRM. So it's will give you legal certainty, high throughput, economic accountability, energy efficient, strong security, low latency, right? And these are the applications where we can apply DRM in blockchain application. So if it will handle million transactions, real-time access, automatic royalty distribution, and it will be obviously helpful for the person who owns the records. Now the conclusion part. So if you see, if you use blockchain, it will enhance security, first important point. Other than that, it will also provide you, if we use consistent mechanism with hybrid mode, so it will faster and it will be useful for the user as well as miners. And it will also provide block propagation based on the network you select. So the network you design, based on that, it will give you different results. And in future, you can use this kind of DRM system with other decentralized applications in DRF as well. So these are the references we have included for our presentation. I hope so I have completed in time. That's all from my side. Thank you all.
Okay, Devesh. I have few questions.
Yeah.
Devesh, if we talk about the several parameters, have you done any optimization of the different parameters, or you keep them as the existing methods?
Parameter in the sense with simulation results.
Yes, you have shown multiple parameters, multiple values, multiple variables are there in your method, right?
Yes, sir. Yes, sir.
So there should be some range of these parameters. How you set the exact optimal value for a parameter?
Okay, correct, sir. So the
Hmm.
thing is that, sir, here we have kept only the algorithm. As I told you, we have proposed this algorithm previously. This is just for DRM. How can we apply for DRM? So we have
Hmm.
not discussed much about the algorithm optimization, but how
Hmm.
this optimal algorithm is useful for the DRM. So as you said, how this parameter is useful for, I mean, which are the parameters we have considered. So there are certain limitations, sir. As I told you, there you can have block if you see all the parameters, let me show you in the slide. If you set the blocks, right, if your priority is number of blocks is mined in higher propagation time, then you can set this parameter. If you are more concerned
Can you
about the
can you move to the formulation part
okay.
before this?
Hmm.
Like this W stack PI, W rep RI.
Hmm.
So, have you kept them as the existing methods value?
This value
Like, what should be the range for this PI, the W stack?
I have kept over here is 0.9, 0.8 to 0.9, that you can set the threshold value. But again, as I told you, it can be modified based on your need. So there is no certain limitations. So if you require this, you can modify up to 10 to 20 as well. Depends on, I mean, 0.12 to 0.2 as well. So if
Okay,
you set,
one more question.
huh,
Uh, what are the quantitative measures to show the performance that can show that your proposed method is performing better than the existing one? Is there any quantitative measures?
yes, sir. See, if you see, these are the different network parameters. So the data you kept in the block, one of the important point. Other than that, the algorithm which is already I mean, these are the simulation tools which is already published and provided data. They have shown these are the results. So these results I have used from the Blocksim and JABS.
Actually, Devesh, I want to know like these comparative analysis you've shown, like features, POW, POS,
Hmm.
OHC, all these are subjective. I can't see the formula how you measure the performance for the that your method is achieving better result as compared to the existing one.
So this,
So
I have
like on which based on which formula I can say that the POW is high or POS is moderate or OHCM is very high. How we can measure it?
as I told you, sir, this is the extension of our work. This is already published, right? Algorithm is already published. I have just used for DRM over here. So I have not discussed algorithm in more detail over here. I have just kept the comparisons of the previous algorithm in DRM application. So that is why the algorithm is not discussed in detail over here. But the parameter you said, as I told you, sir, the block propagation time and the information available on difficulty level that we set, right? That will modify this value, right? So again, the entire mathematical calculation, everything we have already proposed in previous work. So that is why we have not kept over here.
Okay, Devesh, fine. Thank you.
Thank you for your presentation, sir. I'd like to move on with our next paper presenter. I'd like to call upon paper presenter Daniel D with the paper titled Aero Cursor Adaptive Air Gesture Driven Cursor Control Using Dynamic Spatiotemporal Neural Mapping. So, if you're ready with your presentation, then you may start.
Yes, ma'am, I'm ready.
Yeah, please go ahead.
So good morning, sir. Myself, Daniel. So I'm the one of the author of Aero Cursor Adaptive Air Gesture Driven Cursor Control Using Dynamic Spatiotemporal Neural Mapping. So the co-authors are Dr. Vrinda Shetty, Mr. Santosh Vayan, Dr. Prasanna Lakshmi, Mrs. Tanuja, and Mr. Shivram A.S. The advancement of computing technologies had led to a shift in the way human interacts with machines. Conventional input devices such as the mouse, keyboard, although effective, impose physical limitations in scenarios where contactless or spatial interaction is preferable, such as in medical environments, immersive virtual reality systems or assistive technology. The existing systems, what we have, indicate a clear research gap that the absence of an adaptive multi-sensor approach that captures the temporal evaluation and depth dynamics of gestures. The proposed aerocursor system, what we have defined, it introduces an adaptive air gesture-based cursor control framework that integrates spatiotemporal neural mapping with multi-sensor fusion. The system dynamically learns gesture trajectories in three-dimensional space, combining visual data with ultrasonic and interior inputs for enhanced depth perceptions and robustness. Furthermore, this model, what we have defined, it is a context-aware intent estimation mechanism that anticipates cursors destinations based on user motions and gaze patterns, reducing latency and improving control precision. So the problem statement is the proposed aero cursor framework aims to establish a robust, adaptive, and multi-sensor cursor control system that interprets freehand gestures in three-dimensional space, unlike traditional two-image-based cursor. So Aero's cursor, what we have developed, it employs a spatio-temporal neural mapping model that learns gesture evolution dynamically over time, enabling user-specific adaptation and real-time environment resilience. The system integrates RGB visual data, ultrasonic depth sensing, and inertial motion data into a unified processing pipeline to achieve high precision context-aware cursor control without physical contact. So the papers we have referred almost 10 papers. The first one is AI virtual mouse system. So authors are M. Rao, Selvi, Kunjan. See, the demerits what we have analyzed is, just a minute. Is it visible, sir?
Yeah, sir, it is visible.
Okay. So in first paper, we have the demerit, what we have analyzed, its performance is highly dependent on ambient lighting and background coloring. So it struggles with overlapping hands or complex gestures and has a limited gesture vocabulary. So, and the paper second one, so AI powered virtual mouse enhancing real-time gesture control with latency aware jitter suppression. So here the approach demands higher computational resources, especially during multitasking. So the performance of this was 96.1% with a 30% latency reduction. And the paper the third authors were Menon, paper titled Smart Hand Gesture Based Interface for Mouse Control and Interactions. So the demerits what we have identified is, so here its performance is highly dependent on ambient lighting and background color. So it struggles with overlapping. So the accuracy was almost 85 to 88%. So in the paper 4, so the demerit what we have identified in this paper 4 was its accuracy. The system required GPU support for optimal real-time execution and showed minor overfitting on small data sets. So the accuracy was 97.4%. Response time was about 45 milliseconds per frame. So the overall across the papers, what we have identified, ResNet-based systems integrated with media pipeline. Consistency outperformed traditional computer vision methods. But the system uses classical methods like KNN or pure OpenCV, were more lightweight and suitable for low research setups, but lacked robustness. So we have referred few more papers like the title Navigating Interfaces. Authors were Ananya R and Akanksha. So almost the main concentration was on the accuracy and the latency. So the proposed model architecture. So this is the proposed models architecture, Aero cursor framework. So the model consists of 5 stages. The first stage is multi-sensor data acquisition layer. This is the foundation of Aero cursor framework, where the part that collects raw data from the multiple sensors. It uses 3 synchronized devices which works together. First one is RGB camera, second one is ultrasonic range sensor, and third one is inertial measurement unit, IMU. So this using the RGB camera, it captures 2D hand images and landmarks. This helps tracking the basic structure and direction of the hand gestures. And using ultrasonic range sensor, it measures how far the hand is from the system by sending ultrasonic pulses. So this gives the accurate depth information which the camera alone cannot identify. So in this model, so I mean in this stage, in multi-sensor data acquisition layer, we use 3 devices togetherly, that is RGB camera in order to capture the images, and ultrasonic sensors which identify how far the hand is from the system, and third one is IMU model, so inertial measurement unit. So it detects hand rotation, speed, and the angle of the gesture. And coming to the second one, pre-processing and collaboration module. So the data collected by the sensors can be noisy or unstable, especially if lighting changes or the user moves quickly. So it may lead to some noise or unstable. This module fixes that by performing two important tasks. First one is noise reduction and second one is user calibration. So in noise reduction, the system uses Kalman filters to smooth out jitter and stabilize motion data. This ensures consistent readings from all sensors. And in user collaboration, during setup, each user performs a few gestures so that system can record their hand span, depth reach, and movement range. So these two tasks will be done in processing and calibration. And third one, spatiotemporal gesture encoding module. So this includes three vectors. So that is position, velocity, and acceleration. Once the data are clean, the system extracts useful features that describes how the hand is moving. So it calculates 3D motion vectors. So which includes position, where the hand is now, velocity, how fast the hand is moving, acceleration, how quickly the motion is changing. These features are sent to spatiotemporal encoder, a lightweight AI model that understands both space and time. This means the system does not look just only a single frame, it learns the entire motion sequence in this frame. So fourth one is context aware intent prediction engine. So intent prediction and contextual mapping. So it does not wait for the gesture to finish. It predicts what you are trying to do while you are still moving your hand. So instead of waiting for complete hand gesture, it starts predicting while you are trying to do only. So like what you are still doing. So it uses directional vectors where your hand is going on and recent motion history. So previous gestures and context clue such as gaze and head direction. By analyzing these cues, the system can anticipate actions like pointing, clicking, dragging, etc. So this context-aware prediction inspired by multi-model AI models makes interaction faster and smoother. And at last, the cursor control and display interface. So finally, the cursor module translates the recognized hand movement in 3D screen motion. So it uses a motion scaling transformation. So the common gestures are mapped as follows. So pinch, if you pinch, it will take it as click. If you swipe, it will take it as scroll. However, hover. So if you hand over, so it selects. The system also uses adopting threshold, meaning it adjusts its sensitivity depending on how consistently the user moves. So the aero cursor combines visual RGB and ultrasonic sensors and IMU sensors for 3D gesture tracking. It cleans and calibrates input for each users to ensure personalized perception. The spatiotemporal encoder and intent predictor make it context-free and adaptive. So the cursor interface delivers real-time smooth control, touchless across device and users. So this is the implementation and result. So while implementing, so it includes certain stages like data synchronization, data estimation and gesture segmentation, motion trajectory analysis, spatiotemporal feature learning, prediction, cursor mapping, gesture command execution, and but finally, we evaluate the proposed aero cursor systems with three baselines such as accuracy evaluation, latency measurement, and adaptability analysis. So in accuracy evaluation, so Aero Cursor achieved 96% accuracy, outperforming all baselines. This was mainly due to its spatiotemporal learning and multi-sensor fusion. Adding depth and IMU data greatly improved tracking during over accumulations and low light conditions also. So while coming to the latency measurement, so it measures how fast the system responds. The time gap between a physical gesture and the cursor reaction, it was about 220 milliseconds latency. Aero cursor reduced this to so the previous traditional systems, what we were used, it was 220 milliseconds latency, but the Aero cursor reduced this latency to 90 milliseconds. So last one, adaptability analysis. So here, Aero cursor maintained almost 90% performance stability compared to previous models like which were 870 to 87%. So this confirms that dynamic multi-sensor fusion and user calibration enable consistent performance in almost any conditions. So Aero cursor is an adaptive multi-sensor gesture-based control system designed to overcome the limitations of traditional 2D vision-based interfaces. It combines spatio-temporal neural mapping, context-aware intent prediction, and multi-sensor fusion in order to deliver accurate real-time and touchless control. So by synchronizing data from RGB camera, ultrasonic sensors, and IMU, the system captures depth, motion, and trajectory information, enabling smooth, precise gestures in 3D space. So the key results of the system is accuracy will be 96% gesture recognition, and the latency was reduced to 90 milliseconds. So thank you, sir.
Denny, have you considered it only for the hand gestures, right?
Yes, sir. Yes, sir.
Okay, no other gestures you have considered in this work.
Just right. We have just implemented for hand gestures, sir.
Okay, so if I want to test this model, so whether it would be sufficient if I want to use it as a writing pad for teaching?
Just we need to try that, sir.
Okay, so have you identified any limitations of this work?
Sir, limitations in the sense the speed, latency speed may vary, sir. So now, right now we have like 90 nanoseconds. So it may vary, sir.
Okay, thank you, Denny.
Thank you, sir. Thank you.
Thank you, sir. We'll be proceeding
Thank
on
you.
with the next paper presenter. I'd like to call upon paper presenter Gunjan Sonar with the paper titled Analytical Study Green Building Materials and Lead Ratings. So if you're ready, then you may start ahead. Sir Gunjan Sonar. It seems we do not have him in the meeting yet. We'll proceed on to the next paper presenter. Arjun with the paper title Decentralized Web GPU Powered WASM Compute Framework. So if you're ready, then you may start with the presentation.
Good morning.
Yeah, good morning.
Hello,
Yes, sir.
is the screen visible?
Yes, sir, it is visible.
All right.
Yeah.
So I am Arjunar Manyani, and I am with my authors Aniketan Rao, Neville, and Anshita. We're from PES University, and we'll be presenting on decentralized browser-based distributed computing framework. So the problem that we noticed was high-performance computing typically depends on expensive centralized cloud infrastructure, and that typically leads to vendor lock-in and high operational costs. So what we wanted to do was we wanted to create a decentralized browser-based distributed computing framework, which uses your regular systems like your phone's browsers, your laptop browser, your home PC browser, and use all of that compute power to do distributed computing. We've tried it for applications like MapReduce and video processing and web scraping. The technology that we're using is WebAssembly, which is available on every modern browser, and WebGPU, which is also one more technology that's available in every browser. We're using WebRTC for peer-to-peer connection between the different browser nodes. This eliminates the dependency on centralized cloud servers, allowing collaborative computation directly through web browsers. We have task partitioning, fair share scheduling, peer discovery, fault tolerance, and result aggregation. I'll explain more on that when we reach the system architecture. So these are the core technologies. WebAssembly enables near native execution speed. So it's like a virtual machine, but without the overhead of a heavy virtual machine. Also web GPU, WebRTC, and Rust is what is our so we have a package in Rust which allows you to convert your Rust code into WASM modules, which you then send out for distributed execution. So the system architecture begins with the client interface module. So the client writes Rust code and uses our Rust package to convert a function into a WASM module. That WASM module will then be partitioned among different peers. So the peer discovery happens in the network layer. So we're using WebRTC and signaling servers for discovering different nodes. So once those peer nodes are found, the tasks are sent to each of the nodes inside the network. In case any of those nodes fail, we have fault tolerance. So that allows for task reassignment. Once all the nodes complete their tasks, it goes to the aggregation module, which is on the client who initially started the distribution. So that's like the reducer of the network. After that, it's given back to the client as a final result. So fair share scheduler, we use a round robin strategy so that it's equal amount of work given to all the peers in the network. That also comes with load balancing so that no one peer gets overloaded with too much task to be completed. We have fault detection in case one of the browsers goes down or there's a network error, in which case we have fault tolerance so that the task that was given to it is given to a different node. And then we have the implementation. So the user uploads code in Rust, and that is converted to a WASM module. Then we have the task distribution, which takes the WASM modules and distributes it to all the peers in the network through WebRTC. We then have peer execution, which is just each of the peers execute the WASM modules using WASM and web GPU, which is available in their browser automatically. So the good thing about our project is that you don't need any external application to be downloaded. You don't need any setup. You just come to a website and immediately your browser is ready to do tasks for anybody that needs work to be done. Here is a demo of our project. So right now we're starting the servers, and this URL that we've given, will be a hosted website. So whenever you want to use or like provide compute power, you come with your browser to our link and you'll see a page like this. So that gives you a worker ID, and then it also shows the network topology. So as more peers connect to this website, you'll be able to see all the nodes connected and part of the network. Right now there was one peer. So each tab also counts as a new browser instance. So right now we have two tabs. So we see two peers in the network topology. It also works cross-platform. So any device that has a browser will work. So this is a phone and we're going to the same link. So we'll see the previous two nodes as well as the new node, which is this phone on the network topology. And you can see the worker ID there and the worker ID here matches so that we know that what all nodes are available. So now I will execute an example program. So it shows that the resources are being allocated using fair share scheduling. So So we see that this device got a task, as in a chunk of the task, because we want it to be parallel. So this gets some amount of the data. This tab gets some of the data, and this tab will also get some of the data. So the task was partitioned and split across all the browser instances that were part of the network. And each of them computed their own individual tasks, sent it back, and it got aggregated to a final result. The final result is visible there. So these are the experiments we conducted. We tried MapReduce, we tried web scraping, we did video processing, which is just we added a filter. So in web scraping, we ran a example with Selenium as well as our network. Our network had, I think, 4 nodes, and we saw that it completed 17 times faster than Selenium. It can scale infinitely. We tested it with 15 to 25 peers. But since everything is peer-to-peer, we can have n number of peers connected to the network. Small workloads showed minimal benefits because the point of distributed computing is that it shouldn't be data heavy. Like the amount being split or the data that's being sent across the network should be less. So for smaller workloads, the startup time would be the overhead. These are the requirements that were given to us, and these are the tests that we conducted. So for distributed task execution, we had multi-node execution task, and each of them ran parallelly. For fault tolerance, we simulated peer crashes, and we saw that the tasks were reassigned automatically. We saw performance improvement for the web scraping example with 17 times faster than Selenium. We are not platform dependent, so we tested on different browsers and different devices as well. And it worked consistently across because all the browsers right now support WebAssembly and WebGPU. Scalability, we tested with 15 to 25 peers. And we saw linear improvement with the number of peers being added.
Okay,
Then was
Devesh, you can stop. I have few questions.
okay.
So, it is regarding the web GPU. Does it
Okay.
provide the computational resources or uses the node's CPU for the map reduce task?
It uses the node, as in the node that is providing compute.
So it uses the node's CPU.
GPU. Web GPU uses the GPU. WebAssembly uses the CPU.
Okay, so it uses the user's GPU or it
User's GPU, yes.
user's GPU, right? Okay, so okay.
Because we don't want to be doing any computation on our server side. Our
Hmm.
server is just a web server
Hmm.
that hosts the website.
So how secure it is, how you implemented the security in this framework?
Security, right now, WebAssembly is in a sandbox like Docker. So
Hmm.
we don't have access to the user's file system or anything.
Hmm.
It only does tasks that is supported by WebAssembly.
Okay.
Yeah.
So one more question. Why you only chosen the fair share schedulers? Have you explored any recent scheduling algorithms?
We studied it as part of our coursework and it made sense because fair share scheduler would assume you have many nodes. Each
Hmm.
of them will be distributed to equal number of people that want work to be done. But we wanted to do priority scheduling. Like if we were trying to monetize this, we would probably have like a credit system. Depending on which, the more credits you use, you'll have a higher priority and more number of machines to be used. But since right now it's a small project,
Okay,
We
so
wanted
based on the
everyone to.
application, we can modify, right? The algorithm.
Sorry?
Based on the application, we can modify it or adapt the algorithm, right?
Yeah, yeah.
Okay, thank you, Arjun.
Thank you. Is that it? Do I stop sharing?
Yes, Arjun.
Yeah,
Okay.
so you
Thank you.
can.
Thank you.
Thank you for your presentation, sir. We'll be proceeding on with the next paper presenter. I'd like to call upon paper presenter, just a second. We have our next presenter, Veena, with a paper titled Early Identification of Diabetic Retinopathy Using Machine Learning Approaches. Ma'am, if you're ready, then you may start with the presentation.
Yes.
Yeah.
Hello, am I audible?
Yes, ma'am, you're audible.
Thank you. Is the screen visible? Will you please confirm?
Yes, ma'am, it is visible.
Thank you. Thank you. Good morning, everybody. My name is Veena. I'm from Manipal. Paper title which I'm be presenting is Early Identification of Diabetic Retinopathy, which is also known as DR in short, using various machine learning approaches. My paper ID is 699. Authors are myself, Veena KM, Veena Maya, Rashmi Naveen Raj. They are my colleagues. And we have one doctor with us she's an ophthalmologist, Sulata V. Bhandari. She is working in Kasturiba Medical College, Manipal. We belong to Manipal Academy of Higher Education, Manipal. Presentation flow is introduction, related work, similar work which will use DR using machine learning technique, which will identify DR using machine learning technique, methodology, results and conclusion. This is the presentation flow. Firstly, we need to understand what is meant by diabetic retinopathy. It's an abnormal condition. It's related to eye ophthalmology. When blood sugar level is high, it may tend to damage the retinal blood vessels in our eye, which will lead to the complete blindness or partial or complete blindness. It will also lead to the blood vessel damage, retinal blood vessel damage, increased formation of abnormal blood vessels, blood vessel inflammation, leakage of blood and fluid from the blood vessels. It will definitely lead to partial or complete blindness if it is not detected early. So primary solution is early detection and giving proper medication. Mainly the diabetic need to be controlled. Timely treatment and regular eye examinations are the primary solutions for the detecting diabetic retinopathy, to overcome the diabetic retinopathy. This is a sample retinal image where it is very high abnormal retinal blood damage is there, but sometimes it may not be severely damaged. It may be partially damaged on blood vessels. Those will be visible clearly when we take screening. Again, there are many ways to take the screening. But once the retinal images are ready, we may use some techniques, even neural network, AI can be used. But in this work, there is an attempt made to check how the machine learning algorithm may be useful in detecting diabetic retinopathy by using images as input. So there is an attempt made to the model performance of 5 different models: CAT boost, ST boost, ADA boost, random forest, and support vector machine, which is SVM. CAT boost stands for categorical boosting algorithm. XT boost is for extreme gradient boost. Adaptive boosting is ADA boost. Random forest classifier. We have used 5 different public data sets which publicly provide the retinal images along with the diabetic retinopathy condition status. That is the overall introduction to work. Now, the similar works have been carried out by different uh, researchers, different, like, we just here focusing on which and all machine learnings are used. We are not focusing on performance because they'll be using different public data sets. These data sets we have not used in our work. So the first 11th paper, Gayatri et al. Have used Harlick and other dual tree complex wavelet transform features as inputs to the machine learning technique. And the machine learning technique they have used is SVM, random forest, random tree, and J48. And they have concluded by saying that random forest outperforms compared to all other classification techniques. The 12th paper, Reddy et al. Have used all the features which will be representing the detected lesion, image level descriptors are used, and the machine learning techniques which they have focused is random forest, decision tree, AdaBoost, K nearest neighbor, logistic regression. They have concluded that ensemble technique model outperforms. The 13th paper have used 9 different features which are extracted using some statistical feature technique, 3 statistical feature technique and 6 feature based features. They have used random forest as the machine learning technique. Their focus was on extracting the features from the images. The various ways in which we can extract the feature was the focus. The 14th paper have used the image features to take out the images, and the machine learning is applied in 2 stages. In the first stage, KNN, SVM, Navy-based decision tree and logistic regression are used to extract the features. And the second stage, the neural network is added upon as an add-on. And they have seen that the using neural network, the performance is improved. And in the 15th paper, the features are extracted using local binary patterns, and statistical metrics are used to calculate the mean and median. Here also the main focus was on extracting the features, and SVM is used as the classification technique. The 16th paper used local feature extractors, SERP and RISC, and various machine learning techniques are used in the MLP. Multi-layer perceptron is tend to outperform all other classifying techniques. In our work, coming back to our work, in our work, as it is mentioned, 5 different data sets are used, and the amount of images which were used are different from each data set. Even though more images were available, we have chosen manually chosen only the good images which will depict. There were images which were not good, which we have just neglected. So from first data set, which notation APTOS, which was available from 2019, we have used 350 no DR image and 350 with the diabetic retinopathy image, early diabetic retinopathy. Our focus was on early diabetic retinopathy. So B dataset uses 160, 160. We have, in order to balance the class, we have used equal number of normal and abnormal images. The Kegel, we have used 1000 plus 1000 images. ODR, we have used 475 plus 475 images. And DIRD, public data, we have used 150 and 150 images. The 5 algorithm which are implemented were Cataboost classifier. We have used Python classifier classes for this Cataboost classifier, XGBoost classifier, AdaBoost, and random forest classifier. SVC classes were used by the Python. It's a Python implementation. And the results what we obtained, the data sets are numbered, have been mentioned as A, B, C, D, E, and the algorithms are mentioned here. 1A on the data set A, where we use 350 plus 350 images. The Cataboost is, images are so, it could classify that all classifiers have worked well on this data set, but Catboost has outperformed all the other classification techniques. In the second data set B, where we have used 160 plus 160 images, XGBoost is outperforming by using 75.3 accuracy. The P is for precision, R is for recall, and F1 score is mentioned for each label. Class-based label are used. And data set C, again XGBoost is performing well on the Kegel data set, 1000 plus 1000 data set. On data set D, again XGBoost is outperforming compared to all other models. So XGBoost is also outperforming on the data set E, which is 150 plus 150 images. Only in one, if we can see overall performance, only in one model, on data set A, Catboost is a bit better performing than the XGBoost. Other than that, XGBoost is performing better on all the data sets, and it has high average accuracy. So comparatively, XGBoost is performing better than these models which we have considered. This is the conclusion. Machine learning is an important part of the artificial intelligence. Artificial intelligence may lead to higher performance for sure, but with the limited feature extraction techniques, we can use even the machine learning techniques for classification. XGBoost shows superior performance. The machine learning techniques which are studied in this work are CataBoost, XGBoost, AdaBoost, and Random Forest, and support vector machine. It's just an attempt to compare the performance of machine learning models on different data sets, public data sets. XGBoost outperforms by making use of the gradient boosting, which builds the tree sequentially to minimize the regularized loss function, and it optimizes the bias and variance. It gives the higher performance compared to all the other models which we have taken into consideration. This is my presentation. Thank you. Thank you for the opportunity.
Thank you, Veena. We have seen in the different machine learning models.
Yes, sir.
For the few models, you are getting limited accuracy. So, what is
Yes,
the size of the data?
yes, sir. Images, maybe it's not able to classify, but XGBoost is performing well.
Okay. So, how many classes are there? Only binary
Only
classifier?
binary, sir. It is only detection, binary class, detection, only present or not present.
So,
DR, no DR.
in this case, if we have a very large data set, we can switch to the deep learning approaches.
Yes,
So we
yes,
can
sir.
get
That is
the
our
high
future.
accuracy, right?
Yes, sir.
Like
Yes,
the
sir.
multi-layer perceptron-based models.
Yes, sir. Yes, sir. That is future work we'll take into consideration. Machine learning was just an attempt.
Okay, Veena, thank you.
Thank you, sir. Thank you very much.
Thank you, ma'am, and thank you, sir. We'll be proceeding on with the next paper presenter. I'd like to call upon paper presenter Megha Kolekar with the paper titled Model-Based FFT Processor Design for MIMO OFDM Systems with Enhanced Throughput and Reduced Computation Time. Ma'am, if you're ready, then you may start with the presentation.
Thank you, Ishita. Am I audible?
Yes, ma'am, you're audible.
I hope my screen is visible.
1 second, ma'am. Yes, ma'am, it is visible now.
All right. So I'm just putting it in the slideshow mode. So respected session chair and the participants, I am Dr. Megha Kolekar. Along with my colleague, Dr. Prasad Kulkarni, are very glad to present our work with our UG students, Numan, Neeraj, Raj and Tanishka on model-based FFT processor design for MIMO OFDM systems with enhanced throughput and reduced computation time. Our paper ID is 736. This is the overall content of the presentation. So to introduce the discrete Fourier transforms, it's a computational technique normally used to compute the spectrum of the signal. Generally, signals are in time domain and Fourier transforms are used to represent them in frequency domain. Fast Fourier transform is a computationally efficient method. It's a version of DFT, and FFT is based upon eliminating the redundant computations which are often found in the processing of the DFT. So you can say that FFT is a computational version of DFT. There are several applications of FFT processors in wireless broadband communication systems, microwave access, long-term evolution, digital subscriber line, even medical signal processing, etc. MIMO OFDM is a combination of multiple input, multiple output technology with orthogonal frequency division multiplexing OFDM, which is a very upcoming method of modulation technique for 5G and 6G wireless communication. It encodes digital data on multiple carrier frequencies. To talk about the evolution in wireless communication for enhanced throughput, error-free and fading-free wireless communication, we have just glanced through these papers. This is not our literature survey. The work from around early 80s to late 20s, it shows us that there are many methods which are adopted by several researchers for improving the performance of wireless communication. And frequency equalization is the latest technique. But what is common among all these researchers is that all the modulation and demodulation schemes have preferred representation using FFT and inverse representation by using IFFT. So that is the reason we are concentrating our work on FFT. In the literature review, we have various FFT architectures. So FFT is a mathematical concept, but to implement, you need a pipeline. So there is a pipeline and non-pipeline architecture. And the performance indicators for your architecture are the throughput, the area on the semiconductor slice, and the power consumed. So the pipeline architectures are classified as single delay feedback, multi-part delay feedback, single part delay commutator, multi-part delay commutator. Then there is a MRMDF, which is quite popular, and mixed radix multi-part delay commutator. These methods are used for improving the performances over application-specific arithmetic units, arithmetic algorithms, usage of memory, and large size FFTs are often decomposed into small independent computations. So in the literature over in this particular domain, these are the papers, I mean landmark papers, which are spanning from 2000s to up to 2022. So the Lin and Lee give 3 steps radix set FFT algorithm with an MRM-FDF structure. Then Zhu and Fan give radix 2x4 algorithm, 4 parallel data path structures, low complexity and high speed processing. They also have established for MIMO FDM system, but their methodology of implementation is different. Liu and Lee have established split radix method. Bass has established large FFT computations for reduction of arithmetic complexity, and Ye and Jen also have used split radix method. So the takeaway from the review was that in VLSI architectural design, throughput, power dissipation, and area are the key performance indicators. There is always a trade-off between them. Large size FFT computations can be decomposed into small independent computations. Frequent load and store operation with memory available in processing elements decides the computational performance also. Processing elements, adders, delays, interconnects, these all are the components, key components, deciding the throughput and complexity. So the objectives of this research was to design and analysis FFT processor architecture. We have chosen 128-point FFT because that's a very popular FFT used for MIMO FDM structure. The proposed design integrates a multi-operand adder within the complex multiplication stage to improve arithmetic efficiency and enhance the overall throughput. Also, the research interest was to adopt model-based design to accelerate the development cycle and reducing time to market. Because ultimately, any reduction in complexity will lead to early time to market. This is the proposed FFT model. So you can see here, the input stream comes here. It is a multiplex stream. It is splitted into 2 processes, radix 1, which is called as the module 1, radix 2 FFT, and module 2 is radix 8 FFT. And then we perform element-wise multiplication to provide the output. The modularity is further enhanced in this particular diagram. So we have a 128-bit stream, a multiplexer, which then divided into n by 2. So first 64 bits go into this, and up to 128 from 64 go in this particular block. Path 1 is established for radix 8 multiplication. Path 2 is established for radix 2 multiplication. Both are going into memory bank, which is a 32-bit memory bank. And at the output, the outputs of the two are concatenated together. The small radix 2 multiplication block is enhanced over here. It will be having a multiplexer, a single multiplier, which is radix 2, and it will give me a 128-bit multiplication. The complex multiplier with multiple operand adder was designed in Simulink, and this is the block diagram of the Simulink. You have 2 numbers, A plus IB, one complex number, and C plus ID, another complex number. Both are 16-bit integers, and their multiplication for real parts, obtaining real parts and imaginary parts are established using the simulant blocks and concatenated here at the output. So all this, the idea looks quite simple, but implementation is challenging. The snaps of Simulink. So this was our adder and multiplier, and this was the Verilog code that was generated. These are the 2 snapshots. Complexity analysis, the baseline radix 2 multiplication implementation stages, there are 7 stages. There are 448 complex multiplication and 896 complex additions. Hybrid, when we use radix 8 and radix 2 hybrid multiplier, we had 2 radix 8 and 1 radix 2 stage. Their complex multiplication, there are 128 and 64, that is 192 multiplications taking place. By complex, we mean complex number multiplication. And 512 plus 128, that is 640 complex additions taking place. So overall, we have a 57.14% fewer multiplications and 28.57% fewer additions, which mean there is a time complexity reduction as well as area complexity reduction. We verified our magnitude spectrum 128 point sequence with a normalized frequency. We also verified the results for radix 8 using simple Excel multiplication sequence, and the results were matching perfectly. There was absolutely no variation in the results by using normal complex multiplication in Excel and our FFT multiplier 128 point FFT sequence. So when we compare the computation times between radix 2 and radix 8 FFT, if we go for completely radix 2 FFT, then without model-based design, the Simulink multiplier gave 123.5 nanoseconds. With model-based design, Simulink multiplier gave 98.6 nanoseconds. With model-based design, tailored multiplier that we have designed, it is done in 90.6 nanoseconds, which is 26.63% reduction. While the radix 8 with model-based design slightly increased because there is an additional block there. So results, no numerical instability was observed for hybrid decomposition. Twiddle factor application and the DIF combination produce accurate spectral energy distribution also. That is, when we saw the spectral distribution, the spectral energy distribution is accurate and matching with theoretical results. The custom multiplier blocks maintain arithmetic precision comparable to the standard operators, and it is a hardware deployment ready design. So successful HDL code generation demonstrates that the proposed architecture is directly synthesizable, supporting FPGA prototyping. Let me tell you, FPGA is field programmable gated array, which is generally used to prototype any kind of ASICs, that is application specific ICs, for evaluation for low power RF baseband units. This actually confirmed our belief that the model is not merely simulation level, but practical for real-time implementations too. Just to conclude, the proposed 128 point FFT processor developed using a model-based design methodology provides an efficient and flexible solution for MIMO OFDM physical layer signal processing. By enabling tailored modeling and incorporating a hybrid split radix structure, the design significantly reduces computational complexity as well as the hardware overhead. Model-based design enables parallelism exploration. We can have split radix, radix 2, radix 4. It is a pipelined and memory efficient architecture. Throughput versus area trade-off analysis can be done before hardware fabrication. And these features make this architecture highly suitable for VLSI implementation, offering improved performance, low power consumption, and enhanced scalability for next generation wireless communication systems. Our future scope, we can prototype with FPGA, establishing usability with OFDM, because in OFDM systems, the FFT converts time domain signals in frequency domain. There is a IFFT, and MIMO OFDM actually performs all the computations independently for each antenna in real time under very strict latency and throughput constraints. And hence, this FFT processor design is going to dominate the baseband computational complexity, power consumption, and silicon area. So these are our references. And I thank you all for your patient listening to the presentation.
Thank you, ma'am. So, as I understood that it is simulated on a simulator, so you are going to implement it for the device.
Yes, sir.
Right, ma'am?
Yes, sir.
And so at the simulation stage, have you considered the universal test cases?
Yes, sir. It has been taken over universal test cases. There is a test bed for FFT analysis. So this test bed includes some standard tests for accuracy of the results, that is the complex multiplier and complex addition, as well as the energy spectrums also must match. So it has been tested over the standard testing inputs.
Okay, thank you.
Yes, sir. So next we will be doing the FPGA implementation of this device.
Okay, okay.
Thank you so much. I'll stop sharing my screen.
Thank you, ma'am. Thank you, sir. We'll be proceeding ahead with our next paper presenter. I'd like to call upon Chahat with the paper titled optimization algorithm for dynamic network slicing in next generation networks. Ma'am, if you're ready, then you may start with the presentation.
Yes.
Yeah.
I'm audible, ma'am.
Yes, ma'am, you're audible.
And presentation is visible?
Yes, ma'am, it is visible now.
Okay. Good morning, everyone. My name is Jaskiran. Today, I will be presenting our work titled Optimization Algorithm for Designing Network Slicing in Next Generation Network. So the layout of this presentation, like first about introduction, then next is literature review, proposed work, results, and last one conclusion. So according to this layout, in this first slide, I will be briefly introduced I briefly explain the introduction and problem background concept. So in future 5G and beyond network, they are designed in such a way they support the heterogeneous services such as EMBB, URLLC, MMTC with diverse QoS requirement over a single physical network. So these type of design only feasible due to the network slicing feature. So in network slicing feature, they are enables sharing of multiple logical networks over a single physical infrastructure. So these sharing operations make resource management more complex. So in practical system, each slide compete for limited radio and core resources, which lead to more QoS degradation when demand and allocation become mismatched. So static and deterministic allocation methods become fail in dynamic environment, which lead to more QoS violation, more SLA penalties, and reduce service performance. So we proposed a solution and our contribution to compute a accurate demand estimation, which help to avoid over allocation and under allocation, which improve the efficiency and user satisfaction. So in our proposed framework, we employ a J algorithm. It is a lightweighted and parameter free algorithm which are suitable for real-time network decisions. So in this combined network, we allocate the bandwidth to maximize satisfaction, fairness, utilization under the total capacity constraints. These are the main factors which our proposed models composed. So these slides depict the network slicing architecture of 5G. In this slide, there is a main building. What are the main building block of network slice architecture? The main building blocks are services provider, user equipment, core network, and slice orchestras. In this, the service providers give the services to the user equipment according to user QoS requirement. And in core network, the core network manage the network traffic and connectivity, and it deliver the services to the users according to their QoS requirements. So meanwhile, the slice orchestras manage the each slice which are given to the user equipment, and this slice orchestra manage the slides from the slice creation to the slice termination. So this slides depict the how 5G network how slice networking this slides depicts or this image depicts how the slice networking work. About literature review. In this slide, I will briefly explain the existing studies that we reviewed for formulate our research problem. So the optimization techniques which we studied, that is network slice techniques. The main outcome of network slice techniques, they support the reliabilities, mobility in vehicle networks, and it's give the more satisfied rigid delay requirements across tenants, and it's also helped to improve the isolation and orchestration issues. So the main limitation of this network slice optimization technique are it does require the complex cross-layer orchestration, and it also faces the scalability issues under the dynamic traffic. So next optimization technique, that is a deterministic optimization approach, is used for optimization, and these techniques, the key outcome of these techniques are optimal latency performance under stable condition. It's also provide the better services guarantees, but it lead with the poor performance under traffic fluctuations rapidly and high complexities in high computational complexity in large scale networks. And in the if we use the heuristic approach for optimization, the key outcome of using this technique, it's lead to improving the resource utilization, and it's also reduce the complexity and gives the fast execution. But the limitation of this technique, it's not it faced with the suboptimal solutions. Same like the next optimal technique, that is a meta-heuristic approach. The outcome of meta-heuristic approach, it improved the interslice performance, better conversion and load balancing, improve the delay and utilization performance. But same, the limitation which this technique face, the high sensitivity to parameter using and limited focus on the per user QoS. Same the other optimization techniques such as teaching learning based optimization. The key outcomes are, it is a parameter less optimization, and it's give the simple structure, but limitation which this technique face, it's not designed for the dynamic or real-time network slicing. Same as the JA algorithm, it is a parameter less optimization, but the hardly and rarely applied in the 5G and 6G network slicing. Same RAW1, RAW2 and RAW3 algorithm. It is simple metaphors less search strategies, but not directly applied to a QoS driven slices. This all about which we studied the literature for proposed our framework. The next slide about the proposed work. Now I will hand over the presentation to my co-author Chahat, who will explain the rest part of this presentation. Thank you. So good morning, everyone. I'm Chahat. I'm explaining how we will propose the work. So firstly, we will model the system demand model. In this, what is a system demand model? Like we want to allocate the bandwidth depend upon how much data each user need at a given moment. So in this, we use a context-aware bandwidth estimation approach. And if we see that in traditional models, they have fixed demands, rely on a traffic class like non-GBR and GBR, and ignore the real-time condition. So this lead to the over allocation and the under allocation. But in our proposed model, we use the per user bandwidth demand and adapt the dynamic changes dynamically to the changes condition. So to consider these real-time approaches, so we conclude the factors like the delay, packet loss rate, reduce resource metrics, slice level scaling, and priority, which enables more accurate user bandwidth prediction, reflecting the practical 5G infrastructure constraint. So in the next, we use the fitness function. Fitness function is used for the GI algorithm in further. So in this is a decision making criteria, and in this each resource allocation is evaluated using the composite QoS QoS based fitness function. So this tells what to keep or what to discard. So this will lead us to the to avoid the under allocation and the over allocation of the resources. Without this, optimization is impossible. So in this we key 5G performance indicators are the user satisfaction, latency, packet loss, fairness, and the bandwidth capacity constraint. In this, we give the higher weight to the satisfaction because we mainly focus on the satisfaction, then with the fairness, then latency, then the packet loss, and then the penalty coefficient is used to balance between the real possible solutions. So unlike the single metric approach, this model rewards the fair and efficient allocation, penalize the delay, packet loss, and the capacity violation, and this will be accurately reflect in the 5G environment which we are living in. So in this whole model, a higher fitness score indicates the better QoS satisfaction with the strict enforcement of the bandwidth limits. So next is the main JA algorithm, which we have applied to the data set. So JA means the victory, which always leads our solution towards the best solution and repelled away from the worst solution. It used the fitness function to rank the candidate solution. It used the population based and iterative approach, and the R1 X best and XI leads to the attractive toward the best solution, and R2 X worst lead to the repel away from the worst solution. So in these, the R1 and R2 are the random factors which can avoid the premature convergence and lead to the exploration, and the best the attraction term leads to the exploitation. So the J algorithm maintain a balance between the exploitation and the exploration. So so this is a flow chart we have followed, and first we initialize the things like first we define the problem bounds like minimum and maximum bandwidth per user, and then the total system capacity. Then we generate the initial population for the candidate solution. Each solution is a bandwidth allocation vector, and then we define the fitness function which combines the satisfaction, fairness, delay, loss, and capacity penalties. So second step is the JR update rule. In this, firstly, we generate the random numbers, that is R1 and R2. Then we update each solution using the JR rule that will lead toward the best solution and move away from the worst solution. Then we apply the boundary limits to prevent the invalid bandwidth values. So next is the constraint check and repair bandwidth. In this, we check if the total allocated bandwidth exceeds the system capacity. If violated, scale down the allocation proportionally or repair allocation to satisfy hard constraints. Next is the fitness evaluation and solution replace. Compute the fitness for the old solution and the update solution. Compare the both. If new solution is better, replace that. Otherwise, keep the old one. And the last is the global best and the termination. In this, track the best solution found so far. Check the termination condition like maximum iteration reached or fitness convergence achieved. So the data set we use is network data set. In this 31583 user sessions are there. Total of input features are 17, but we use the only traffic type, that is GBR, non-GBR, QoS metrics, packet delay and packet loss, connectivity, whether it is LTE or 5G access, and the user context, whether what is the device category, IoT indicators, and the class size, whether it is EMBB, URLCC, and MMTC. So after applying the optimization algorithm, we reach to the results. Before optimization algorithm, the QoS satisfaction is 0.333, and after applying the optimization algorithm, it is 0.6333. And same for the fairness index. Before applying the optimization, the results are 0.5802. After applying the optimization algorithm, fairness will increase by 0.9812. Same with the average packet delay. Before applying the optimization algorithm, it is 0.3188. After applying the optimization algorithm, it will decrease to the 0.2912. As we know that delay has to be low, so after applying the optimization algorithm, the delay is decreasing.
Excuse me, ma'am.
Yes, ma'am.
Yeah, please go ahead. I was just reminding you about the time limit. Yeah.
Okay. So the conclusion is that we propose a QoS driven and context aware demand. This will accurately estimate user bandwidth by incorporating all these features. So after applying the GA-based algorithm, the user satisfaction will increase by 3%, and the fairness will be increased by the 4%, and the latency performance will be decreased by the 1%. By applying the GA algorithm, these gains are achieved by without increasing the computational complexity. Thank you. This is the acknowledgement, and these are the references which we referred. to propose our framework. Thank you.
Chahat, I have few questions.
Yes, sir.
Have you considered any other optimization algorithms for the comparison?
Sir, recently I haven't used, but in future I will compare the Venkata Rao other algorithm. Like recently they have launched the BMW and BWM, so I
Like,
can.
okay, so as I can see that the ZI algorithm's limitation is its latency, its tendency to get stuck in the local optima. So that is the major problem of this algorithm. So have you employed the original GI algorithm or its enhanced variant?
I, I applied the original GI algorithm, not the enhanced GI algorithm. So I
Okay.
use the GI algorithm with the 5G architecture to
Okay.
improve some factors like less to complexity and improve the fairness.
You can consider more enhanced version for this algorithm, right?
Okay.
As have few key limitations like premature convergence limitation, limited exploration power, and so on, right?
Yes, sir.
Okay, thank you, Ji. Thank you, Chad.
Thank you, ma'am. Thank you, sir. We'll be proceeding on with our next paper presenter. I'd like to call upon paper presenter Asha Durafe with the paper titled Quantum Resistance Cryptography for SCADA Systems Enhancing Security in the Quantum Era. Ma'am, if
Yes,
you're ready,
ma'am.
then you may start with the presentation.
Yes, ma'am. Am I audible?
Yes, ma'am, you're audible.
I'll just share my screen. I hope my screen is visible.
One second, ma'am. Yes, ma'am, it is visible now.
Okay. Good morning, all of you. Myself, Dr. Asha Durafe from Shayan Anchor Kachi Engineering College, and I'll be presenting quantum resistance cryptography for SCADA systems, enhancing security in the quantum era. So now this work actually is predominantly about the SCADA system, that is the industrial control systems, which are basically the supervisory control and data acquisition systems, which are playing an important role in critical infrastructure tasks like energy, water, transportation, and so on. Now, quantum computing advancements, these are having various cryptographic algorithms like RSA, DSA, elliptic curve cryptography for significant security risks. But all of these algorithms are breakable. So we have to just amalgamate all these algorithms or any of these algorithms with the quantum security features so that the potential breakability is avoided. Now, this work is basically the potential use of quantum resistance cryptography to handle the future risk in SCADA systems, and it is proposing an architecture for SCADA system with IEC 60870-5-5104 network protocol for the SCADA systems and QKD enabled encrypted communication. It is reviewing some quantum proof algorithms and protocols and then suggesting ways to upgrade the SCADA security using post quantum cryptography. So the motivation behind this is the critical infrastructure which is to be managed, because the critical infrastructure basically uses SCADA systems which natively does not have any security features to avoid the security attacks such as man in the middle attack or eavesdropping attack. So to avoid these kind of attacks, we have to have some kind of strengthened algorithm so as the security can be enhanced. So quantum computing, which is along with RSA or ECC or DSA, can be used, and then future ready security can be implemented in the SCADA systems. So the problem statement is the conventional cryptography, which is vulnerable to quantum attacks, can be avoided, and then the SCADA systems should have a long operational life cycles without only possible attacks. So the objectives are to study quantum threats to SCADA, analyze the post-quantum algorithms, and propose secure SCADA architecture. Now here we have studied some Shor's algorithm breaks using RSA and ECC algorithms and Grover's algorithms, which is possibly weakening the symmetric encryption techniques such as RSA. The literature survey which we have done is actually about the essential infrastructure elements which are managed by SCADA systems. So what I have seen in that is quantum computers are effectively solving the problems related to discrete algorithms and integer factorization. Now, quantum cryptography is not only about the mathematical complexity, but it is about the properties of physics. Like here, the bits or the information is transmitted in the form of photons, that is light particles, very small light, tiny particles. So here, the cryptography is all about the method by which, or the quantum state by which the information is transmitted from the control unit to the remote station unit. So here people have done quite a good amount of work, and what they have stated is the increasing threat to conventional cryptographic system by quantum computing has led to quantum resistance cryptography and its amalgamation into core infrastructure projects such as SCADA systems. The NIST, that is National Institute of Standards and Technology, has also begun a standardization drive to test and select post-quantum models that can replace RSA and ECC algorithms, and they have also released an important data on several families of quantum safe algorithms such as lattice based, code derived, or multivariate encryption methods, I think, which is given in the literature. The XMMS, that is the hash-based signature scheme, is also proposed and well suited for restricted environments like SCADA. So these are the researchers who have worked. Tremendous amount of work has been done on this, and the key findings are as described here. So the SCADA systems which are available are actually having the sensitivity, the security sensitivity of SCADA, and other studies have focused about the performance effects of deploying post-quantum cryptography. The other work or the NIST's internal test beds, they also have demonstrated the potentials for the hash-based cryptography, but these tests were conducted on both the sets, and what they have found is the hardware requirement for the implementation of these systems is quite complex. Though the physical implementation of QKD, that is quantum key distribution based security methods, has been done actually in some part of China, that is the majority, we can say majority part of the smart grids of China are using QKD based security for their SCADA systems which are handling smart grids. Also in some part of Switzerland, they have used for smart grids this kind of QKD based security, and some part of Europe also is using this kind of security. So these are the quantum resistance algorithms: lattice based, code based, hash based, and QKD, that is quantum key distribution, which is majorly elaborated in this work. So the proposed architecture is actually based on IEC protocol, which is mentioned here for SCADA, QKD enabled key exchange, and advanced encryption standard encrypted payload, that is the symmetric encryption payload. So this is the proposed SCADA system. So here we have majoritarily 3 to 4 units. That is, one is the MTU, that is master terminal unit. So whatever are the threads which are coming to the master terminal units and going to the remote terminal unit should be avoided. So here majoritarily the hardware consideration is to be done to provide backward compatibility with resource constrained SCADA devices. So key management is of utmost importance, because if the keys which are distributed remain safe, then the attacks can be avoided. So here the threats from quantum computing technology will continue to grow, but the proposed model combines this QKD and provides encryption keys with unconditional security between the main transfer unit, that is the master transfer unit, and remote transfer unit. This configuration adapts QKD to establish pass private key encryption keys between MTU and RTU, separate from direct contact via conventional optical keys over the quantum channels, which are usually photons in fiber optic or composite cables. So the key features here are it uses quantum entanglement and or it can use BB84 protocol also. So one of the method we have tried, that is quantum entanglement, and it is used to detect eavesdropping attempt during the key exchange. The private key algorithm, that is AES, is applied using keys supplied by the QKD system. So this is the MTU RTU secure communication framework, where QKD channel is used for distributing the keys from the MTU, that is the master unit, to the lightweight cipher. Then it is transmitted either wired with the wired channel or wireless channel to the field bus or to the network bus. So the key updation takes place regularly to ensure utmost confidentiality, because in quantum it has the feature that whenever it is something is measured, the quantum states, if they are measured, then they get disturbed. So whenever the state is disturbed, there is some anomaly detected and immediately the keys will be changed. Okay, the original keys which are disturbed by eavesdropping or by the attacker, they will be discarded and new keys will be generated. So this is the methodology which is used. First step is QKD key generation, then secure key exchange, data encryption using AES, transmission, and then decryption. The performance evaluation which is done, so the results which we have got here, the key exchange which is at initial phase with AES 256, which is the conventional unit, and with QKD AES, that is quantum secure via BB84 protocol. So there is the change which we can see at the initial phase, then the round trip time which is compared, packet loss under the network stress is compared, eavesdropping detection rate. So here we can see without encryption and even with AES 256, the eavesdropping detection is not detectable, but using QKD AES, the detection rate of the eavesdropping attack is 100%. Key refresh interval is almost the same. Data integrity is much more because it is quantum secure. So any measurement disturbs the state and immediately the attack is detected. Quantum bit error rate is less than 5% for safe threshold. So this is the performance analysis which is done with no encryption using AES 256 and QKD AES. Also the key exchange time comparison. The encryption overhead for IEC 104 packet and the quantum bit error rate. Here, this slide shows the comparison of cryptographic algorithms for SCADA environment. So when we just use RSA, for example, RSA 2048 bytes, where the key size is 2048 bits, the security level is medium and the suitability for SCADA is low because there is no native method available for detection of the attacks. Even if when elliptic curve cryptography is used, the key size 256 is there, but the suitability is medium. Lattice based, the suitability is high, but detection, that is the detection of eavesdropping or man in the middle attack, is not present. Then in code based MACless or hash based techniques, the suitability is high, but detection rate will not be that much. But in quantum key distribution, the severity level is highest. Immediately the attack is detected and the suitability level is medium because the hardware requirement are much more. So that is the future scope of this work. So this is the adoption readiness rate based on the implementation of the pilot projects which are implemented as per the case studies which are described in this work. So according to this, the different readiness levels are detected. So the challenges to this implementation is basically hardware dependency, integration complexity, and cost consideration. Implementation cost is very high because the overall hardware which is required, right from fiber optics to the QKD devices, because the transmission happens in the form of light. So implementation complexity is also high. So the future scope remains the same, that is the lightweight post-quantum cryptography methods, hybrid crypto models can be developed, and scalable QKD deployment can be done so as to get larger implementation overall for increased security and increased privacy methods. So here the quantum safe cryptography is very much essential for securing the SCADA systems, and so a proactive and phased migration strategy which is backed by the standard and government policy can help for this particular industries to have the infrastructure, the critical infrastructure in most secured mode using the quantum era. The real-world pilots and retrofitting projects have shown that these transitions are feasible with the right planning, making it crucial for public and private sectors to act now. Because very few countries are now into this particular pilot projects. There are some pilot projects which are yet running in Japan and some part of Europe where they are on the research phase right now. But few countries like China and Switzerland, they have already implemented and shown that the transitions are feasible, and with the right planning we can achieve greater security in the SCADA systems for critical infrastructure. These are the references which I have used. Thank you, sir.
Thank you, Dr. Asham. I have one question.
Yes, sir.
So, have you tested it under the different attack scenario?
Yes, sir. Actually, some of our students are working in one of the SCADA based technique in industry. So there we have tested for man in the middle and eavesdropping. So there the error rate which was using the quantum, because here actually the simulation work was done in institute, and the actual implementation we can actually connect it with the SCADA system, and it was done on the SCADA system for eavesdropping and man in the middle. So there the bit error rate was quite reduced.
Thank you, Asham.
Thank you, sir.
Thank you. Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon paper presenter Sanjukta Halder with the paper titled Social Sensing Privacy, a Review of Regulatory and Technical Solutions. Ma'am, if you're ready, then you may start ahead.
Hi, good morning, ma'am.
Good
Yes, I would like to begin with my presentation. Thank you so much for the introduction. Ma'am, is my screen visible?
Yes, ma'am, it is visible.
Okay, I would like to go ahead then. Hey everyone, and good morning. Today I'll be presenting our research on social sensing privacy, review of regulatory and technical solutions. This paper, it explores the gap between the laws meant to protect us and the technology we use to actually secure data. So this was a collaborative effort between myself, Mrs. Sanjukta Haldar, and my colleagues, Dr. Smita Goswami, Nandakumar Haryan, and Shailesh Yadav. Now, to begin with, So what is social sensing? Basically, it's how systems use our digital traces like phone data, IoT sensors, and social media to figure out how we behave and interact. The problem is that this collection is often always on and invisible. So the data that that is being collected, it is not always told to us, and it is always invisible. So our research, it found that we usually treat the law and the technology as two different worlds, but they really need to work together to be effective. Right. So now there are certain core privacy threats in social sensing, and one of the biggest risk we identified is what we call as the mosaic effect. So this is where tiny harmless bits of data, like maybe a timestamp or a location ping, they are all put together to reveal very personal things like your health or your relationships. For example, studies show that just 4 location points are enough to identify 95% of people in a supposedly anonymous data set. Right? So simply removing your name isn't enough anymore. So like pictures and our name and our surname, removing them is not working anymore, because even smaller things are revealing our much more data. Right? Now, moving ahead. So we have certain global regulatory landscape, which we have named them as the GDPR. Now, looking at the law, the GDPR in Europe is the big benchmark, but it struggles with social sensing. And why is it? Because social sensing is inference driven. So even if you didn't give a company a specific piece of data, they can infer it from your patterns. The law doesn't always know how to handle these derived insights, especially when you ask for your data to be deleted. Correct? So, in the US, China, and Brazil frameworks, we talk about all of these other countries having different approaches. So, California's law focuses on your right to opt out of your data being sold. China's PIPL is very strict about data leaving the country, while Brazil's LGPD has special rules for research. For a company operating globally, this creates a patchwork of rules that are hard to follow without any flexible tech. Now, there are certain technical privacy enhancing technologies that we speak about. So, on the technical side, we looked at some cool solutions. Differential privacy adds a bit of noise to data, so individuals can't be picked out. So, that is one privacy enhancing technology that can be introduced, and we can definitely put them to use. Federated learning is another big one. It lets AI learn from your phone without ever actually sending your private raw data to a central user. So that is where AI comes into the picture, and AI can definitely be used to protect our privacy. Right. Moving ahead, we also looked at machine unlearning, which is how we try to make a system forget a specific person's data. We have also made a certain comparison between all the regulatory remedies versus the technical mitigations. So in this table, you will find that from our paper, we compare what the law wants versus what what technology can actually do. For instance, the law wants data minimization, and technology like federated learning helps us with that. But then there are still gaps like consent fatigue, where people just click I agree because the settings are too complicated. Now, there are also many major regulatory and technical gaps. So, the biggest gap we found is that static consent, that one time click, it doesn't work for a system that's constantly sensing you in the background. Also, these systems are so distributed, involving phone makers, app developers, and cloud providers, that it's hard to tell who is legally responsible when something surely goes wrong. Right? So this is where we are now moving towards a design ecosystem. And to say more about this particular ecosystem, we can definitely say that we can put into use an integrated framework. So compliance, it cannot rely on isolated legal mandates. It requires a socio-technical framework aligning legal, organizational, and technical layers. There are also context-aware models. So in this particular context-aware models, protections should automatically adapt to situational sensitivity. For example, higher protection in a hospital versus a public park. And of course, if we want to make our ecosystem more reliable and more privacy driven, we can definitely make use of quantifiable metrics, which helps us in developing standardized privacy budgets and re-identification of risk indices for consistent auditing. Only when the government and the individuals, they are more aware of social sensing and the threat that it has on humanity, we can join our hands together and work towards a better future. Right. So there are major, like we were talking about the major regulatory and technical gaps. One of them is also very in emerging architectures like edge analytics. They blur the lines between who controls the data and who processes it. So only after government intervention, these can be clear about, right? Then we also have something called the learned derivative. So current laws and technology, they struggle to handle the removal of information once it has been integrated into a trained AI model. So as AI is helping us with gathering data, AI should also be used to help us in erasing the data. So that is where we can make use of AI in a very smart manner when we talk about social sensing. Right now, talking about the future research directions of this particular topic, which is social sensing, I would like to add upon that neither the law nor the technology can solve this alone. Moving forward, we need to focus on making privacy protections automatic and building tools that can hold systems accountable across different countries. So just like you can easily automatically add on to your data, to your address, your phone number, your name to a particular website, it gets automatically generated. Correct. So similarly, we need to have technology in place where it automatically gets erased also. And like I said earlier, this can only be done if the government, the people, and the people governing our technology, they come together, and we can definitely hold systems accountable across different countries. With this, I would like to conclude my presentation. Thank you. And I'm happy to take any questions regarding our research.
Thank you, Sanjukta, for highlighting the social data privacy concerns, laws, and the possible mitigation
Right,
strategies.
sir. Right, sir.
Okay. Thank you. I have no questions.
Okay. Thank you so much, sir.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon paper presenter Shrishti Mathur with the paper titled Software Supply Chain Vulnerability Analysis and Visualization. Ma'am, if you're ready, then you may start with the presentation.
Yes, I'll start. Am I audible?
Yes, ma'am, you're audible.
Okay, I'll just share my screen. Is the PPT visible?
Yes, ma'am, it is visible.
Okay. So good morning to one and all present here. I'm Srishti Mathur and I'm a student of PES University in Bangalore. Today I'm here to present my paper, Software Supply Chain Vulnerability Analysis and Visualization, with the paper ID 674. The authors are myself, Srishti Mathur, and my co-author Varshini M. And we were guided by our mentor, Dr. Nagsundari S. So to begin with the presentation, I would like to first reinforce on what a software supply chain attack is. So software supply chain attacks are a growing, recent, and yet a very substantial threat to the software industry, and they occur through the exploitation of the security vulnerabilities in major third-party suppliers who act as small developers in larger software development organizations, and they result in widespread breaches. There have been multiple efforts in the related works on investigating the origins of such attacks and how the attacks were carried out, like one of the first being the SolarWinds breach, which occurred in 2020. But there still remains a very important milestone step of advanced visualization tools, which can identify underlying patterns and any kind of trends which could help in predicting future vulnerabilities, and further expanding them to the security tools of the third party environments which are used. Further, we also introduce an approach for uh, uh, giving the output for a vulnerability severity based on the CWE inputs, etc., which I will be explaining in the future slides. So just to reinforce the problem statement, supply chain attacks, specifically software supply chain attacks, are on a rise, and they focus on attacking the supplier's code, or they access the data, all of which eventually exploits the trust of the customers in the entire supply chain. And this is something which is not very good for large software organizations, because often these attacks don't occur because of the security infrastructure of the larger organization, but due to the loopholes within a software vendor. So this is how a typical supply chain looks like. There is a software vendor which will develop and package a part of the software used by a larger organization. And that is often put into a hosting infrastructure, where this is where the cloud environment comes into play. And here the software packages are there available for download. At the end, they are downloaded into the infrastructure of the target. And each link between these few steps could act as potential entry points for manipulating the software and for data exfiltration. So the three primary objectives of the paper include: first is the vulnerability visualizations, where we use the known CISA, known exploited vulnerabilities catalog, and we develop comprehensive to convey the spread and extent of these vulnerabilities through various types of graphs, time graphs, pie charts, stacked bar charts, etc., which help to understand where the vulnerability lies. Secondly, we try to enhance the functionality to a third-party developer use case, which is the Node Package Manager. And we use its tool, NPM Audit, which is a security tool, which is not very often used because of its limited functionality. And we try to showcase the vulnerabilities in these NPM packages through visualizations. And lastly, we have a severity predictor, which is a framework for evaluating and predicting the degree of the vulnerabilities. So just a brief highlight on the data set which we're using. As I mentioned, we use the CISA catalog, and we have multiple attributes in the data set. A few of them have been mentioned here, and I've grouped them for the ease of explanation. So there are few attributes for the identification of the vulnerability, like the CWE ID, or the Common Vulnerability Enumeration ID, which is a widely upheld identification. And similarly, we have certain vulnerability details, like its short description, the CWE category, and the risk metrics. And there are few metrics which we have derived out of the categories, the short description, etc., which are like the attack vector, like network, local, etc., and the cloud impact, to extend the functionality of how it affects the cloud components. So the implementation has the few steps which I told you are relying on our three objectives. The first is we develop visualization dashboards. So we examine the data set and capture essential patterns. We deduce time graphs. Time graphs are very essential to understand how and why were the software vulnerabilities occurring and what change in the software infrastructure helped to prevent them. We have CWE and severity based stacked bar charts. And we also have charts corresponding to the affected cloud category, like is it affecting the software or the infrastructure, and specifically which component, is it the data or the code. And we used Python libraries, pandas, and Flask to implement this entire software. Then we run the NPM audit data analysis, wherein we run a package.json file, which contains all the packages which we use in Node Package Manager. And we extract and parse data from a raw JSON output to present meaningful representations. Lastly, we have the severity prediction model, which is a SEC-based model. And we have three categories. Because we have three categories and they are linearly separable, we use a linear kernel with a one versus the rest strategy because we have multi-label classification, and SVC model is inherently binary. So we use the one versus rest strategy for the classification. And the three inputs which we require for this model are the CWE category, the attack vector, and the short description. And because we have leveraged this on the same data set, we have these inputs available for training. And finally, we provide mitigation steps based on CWE as a part of an extension of this model. So this is a short video for the implementation of the same. So these are the three main factors. The dashboard is the first part. And here we present certain plots. So you have by count, you have time graphs, and you have CWA graphs. Then based on the cloud category, we have which category it's affecting, and within that, how is it affecting the data or the network or the code, etc. The second part is the NPM audit. Here we upload a package.json file, and this is how it runs internally. It is very hard to actually parse this data, and that's why it is not used. And now we extract meaningful data from it, like the top packages, what is their CWA classification. And the final is the severity predictor. And based on the CWA, we transfer to the URL for the common weakness enumeration to understand the potential mitigations and detection techniques. So this is what the implementation focuses on. So just a snapshot of the results which were shown in the video. So these are how the dashboards look like. This is based on specifically when you're talking about the vulnerability trends. And for cloud, if you choose the category of cloud, it is based on more of how it's affecting the cloud arena. This is again one example of the output. So it's seen in this particular vulnerability for this organization, maximum effect is happening in the management and governance, and that could probably further be broken down into how it's affecting the access control and the application data. The results for the NPM audit, we took the meaningful extractions from the JSON file. We identified the top packages by vulnerabilities and the CWEs so that the mitigation can be carried out effectively. And this is the result of the model. The overall precision is around 78%, and the recall and F1 score is high for critical and high. We see that there is a dip in the medium because the features overlap highly with the adjacent classes of high and critical and medium. And because we have a limited data set right now, because this vulnerability is still very recent, the amount of training data is a little less. However, as a future scope, we would like to involve real-time data extraction and obviously appending the data with as and when new vulnerabilities are discovered, which would substantially improve this predictor model. So these are the outputs. So to conclude, I would just like to say that our visualizations act as an essential planning step, and they help in detection, analysis, trend analysis, all of which act as early warning systems based on the past vulnerabilities for the cloud service providers, for the third-party vendors, as well as for the larger organizations which utilize the third-party vendors. And these trends help to identify the weak links in the supply chain, help to group them by CWE, and accordingly understand the mitigation techniques. Also, the foundational ML model we have can be enhanced further to derive more actionable insights and to increase their precision based on more real-time data collection. And that overall will strengthen the security posture of the organization. These are some references which we used. A lot of them are articles in magazines also, because right now a lot of the research is just based on a review of the attack. Not much of mitigation has been found out yet. And with that, I'd like to conclude. Thank you so much for the opportunity to present the paper.
Thank you, Srishti.
Yes, sir.
Can you discuss the data set you chosen for this work?
Yes, sir. So I'll just go back to the data set. So, sir, we have used the CISA known exploited vulnerabilities catalog, and the CISA is the Cybersecurity Infrastructure and Security Management Agency. And this particular catalog does not specifically have only supply chain attacks, but a majority of them are the supply chain related attacks. And it has certain attributes like CWE ID, the name of the vulnerability, as well as the vendor project which it affected and what was the affected product, and certain short descriptions, the category. So these were what were given, and from there we try to deduce certain more attributes which would help us in further understanding of the issue. So we extended it to cloud and the exploitation scope.
So in future, would you be able to consider the real-time data for the different organizations? Is it?
Yes, sir. So that is what we aim to do as a future work, because it's very important to be up to date with the security vulnerabilities. Just leveraging on historical data could be a limiting factor. So definitely we can, as and when any attacks are being carried out, they can be appended and we can automatically use that data, because none of the three implementations which we have provided are dependent on a fixed data set. It can be used with variable data sets as and when required.
Okay, thank you, Srishti.
Yes, thank you so much.
Thank you, ma'am. Thank you, sir. I'd like to call upon our next paper presenter, Gunjan Sonar, with the paper titled Analytical Study Green Building Materials and Lead Ratings. So if you're ready, then you may start with the. Sir Gunjan, we can take you up in the next session. So this brings us to the closing of the session. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCon 2026. I'd also like to thank our session chair for chairing the session. A token to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you very much, Ishita.
Thank you, sir. So would you like to say some words?
Ishita, actually, I have one more meeting, so
Oh, okay, sir. No issues. So right before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone.